Okay, so this is our 6th-hour discussion about the Mass and Change Lab. Here's some of our data up here, first 4 stations. Notice, by the way, anything you notice in particular if you look at the first 4 stations data and then compare that to the last 4 stations data? Anything you notice at all? Numbers are higher in the last 4 stations. It's interesting. I wonder why that is. All right, so we're going to start with station 1 where we burned a wood splint. And that's going to be Maya is going to tell us about what her group said about the wood splint station. So first of all, Maya, when you guys looked at this data for the wood splint station, did you think there was any of it that we should probably kick out? Or is it okay? What's that? What'd you guys say? Was the data all right, or was there something we need to get rid of? It was okay? All right. So what was the general trend there that we saw with the wood splint? According to the data, what happened to the mass? It decreased. It went down. Okay, it went down a little bit. So burning a wood splint, did that make sense to you guys that the mass should go down a little bit? Yes, it did. Okay, why? When you burn the wood, what happened? Some of it went into the air. Some of the particles went into the air. Okay, so I'll put mass lost here. Anybody else want to comment on that? Why they agree or why they disagree? Nobody? All right, we'll go to station 2 then. Melting ice. Melting ice. And this is going to be data. So where's data? Okay, so what did you guys say about the melting ice? First of all, any of those numbers that we need to get rid of? Maybe the 0? How come? Is it a lot different than the other numbers? Is it? So if we look at these other masses, I mean, this is only 0.17 grams, 0.5, 0.09, 0.09, 0.0. I mean, those are pretty small numbers. All of them are within a gram. So when I say numbers we should get rid of, like if I looked at those and then another group had like plus 55 grams, that would be really weird. And I would assume probably something went wrong. But all these data points are pretty close together. So I think they're okay. What was the general trend then with the melting ice? What does it look like according to the data? What happened? Increased. Okay, so we gained a little bit of mass for each group, right? What did your group say? Did that make sense that when you melt ice, we should gain a little bit of mass? Okay, how come? Because it's turning into water. So when ice turns into water, we'll have more mass. Anybody disagree? Okay, so mass should be gained when ice melts. So let's think about what that really means. If we were to make a model of that, and we talked about this earlier a little bit, we said that the mass is really like talking about the amount of particles, right? Do you guys agree? Is that true? If we're talking about mass, we're talking about the amount of particles. So when ice melts, particles must be coming from somewhere. They must be added. That's what you guys are saying? Where are those particles coming from? Anybody? Any ideas? Think. Or should they not be added? Or should particles be leaving? Okay? And this is just the first part. We're going to discuss this stuff. When you guys actually go to make models, you might say to yourself, hey, wait a minute, this doesn't make sense. That's the whole point of part of the process of modeling. All right, so we'll go on to station 3 where we pulled steel wool apart. And this is going to be Eric. Where's Eric? Oh, same group. Okay. So steel will pull apart. First of all, do we need to get rid of any data? Want to get rid of the 0.53? Does anybody disagree with that? Should we get rid of the 0.53? Is it necessary to get rid of the 0.53? Anybody want to speak up? Feel free. You're not going to be judged. Okay. Get rid of the 0.53. How come? Because you're breaking it into smaller pieces, so it doesn't make sense that we should gain mass. Is that what you're saying? Okay. So couldn't we say that about number 2 also? Okay, I see where you're going now. I was going to say that those numbers all seem to be pretty close together, nothing crazy. And remember, there is always going to be some error in measurement, so they could still be okay. But I get what you're saying. So you guys are saying what then? You're saying the mass should not have increased. It should have stayed the same or been lost. Okay, why? Anybody want to add to that? Any agreements on that explanation? I thought that's pretty good because actually thinking about the observation, and I know using the steel wool and pulling it apart, I wound up with steel wool on my fingers. We probably lost some on the table. I know there was a bunch of steel wool, little particles of steel wool all over the balance when I cleaned it. All right, so it makes sense. We probably lost some particles of steel wool. All right, excellent. Thank you. Okay, station 4 where we burned the steel wool. Brenda, you want to tell me what your table had to say about burning steel wool? Is there any data there that we need to get rid of, first of all? Somebody had 0.01. I mean, that's a very small difference. I mean, you could see why they got that, right? Everybody else got no change. So, I mean, like I said, so you're going to have small amounts of error. That's okay. All right, so what's the trend look like? No change in mass. Did that blah, blah, blah. Did that make sense to your group? Did your group say when you burn something that the mass shouldn't change? Or what do you think should have happened? What did you guys say about that? Anybody want to help her out? What did you guys say about that one, burning steel wool? I said, do you guys want to help Brenda out with steel wool burning? She said they look like they stay the same, and I was asking, is that what you guys thought should have happened? It is. How does that compare to Station 1, though? Like in Station 1, we burned something, right? Does anybody else want to disagree with the mass being the same? How come when we burned the wood splint, we expected the mass to be lost, but when we burned the steel wool, it's cool that it just stayed the same, mass wasn't lost? Any ideas on that? Marcus? The two objects that were burning had different masses. Good point, good thinking. Maybe that explains it. Marian? Made of different materials, different masses? Is that what you're going to say? Okay, so maybe that accounts for it. Okay, good, thank you. Let's move on to Station 5. Station 5, we dissolved sugar in water. So this is going to be Zach. Zach, what did your group say about dissolving sugar in water? Any numbers we should get rid of there? Seems like a pretty big range of numbers. We've got minus 102, we've got plus 102, we got lost 0.2 grams, we've got lost 102 grams, lost 0.04 grams, lost 98.08 grams, lost 39 grams. What did you guys observe at this station, first of all? It would be more. You think the mass would it would increase. Oh, that's right. Mass up. Anybody disagree with that? That's what you thought. Is that what the data says? The data doesn't say that, so you guys thought the mass should go up. Why? Wouldn't it be the same? So that's not mass going up, that's mass being the same. So you guys think the mass should have been the same or mass go up? Both? Okay. You assume that mass would be the same? Dylan, what did you think? Sugar dissolving water, if we compare the before to the after, should the mass go up, stay the same, go down? What do you think? You got three choices. What is it? Stay the same. Peyton, is that what you thought then too? Marcus? Okay, so the mass stay the same. But this data, and maybe everybody can help me with this. Data definitely doesn't show that. The data shows big changes. And this is why I pointed out if we looked at those first four stations, all the numbers are fairly close together, no big deal. Now once we start getting in the last four stations, we start seeing some big changes. Why is that? Do you think? Do you remember anything special about these four stations? Brittany? That's true. I didn't give you specific amounts, but should that matter really? Because we're really just looking for a change in mass. Here's what happens. Here's a big amount of error. It's tough for me to get everybody to do this the right way. I've done this for a few years now, a couple years now. So when we do the mass before, say we're doing the sugar and the water, we're actually supposed to take the mass of the sugar that we used and the mass of the water, and we need to add those together to get our mass before. And so sometimes, and that's what we actually compare to the mass after. So sometimes that's part of the problem. We're also finding two different masses. So sometimes we forget to zero out containers. Okay, so that's why on these last four stations we start to see some more mistakes. So when we look back at this data here, if the mass is the same, that means this data, I mean, we're just kind of reasoning that it should stay the same. But when we look at this stuff, why would it lose 102.01 grams of particles? Where would they go? Okay, these are the questions you want to ask yourself. You're going to model this, and you're going to have to draw it and show me where did those particles go. Or if it gained 102 grams, where did it gain 102 grams of particles from? That's a lot. Okay, if you think about it, the mass of the water, you put in 100 milliliters of water, the mass of the water alone was about 100 grams. So you're telling me you lost that many particles or you gained that many particles? Where'd they come from? Same thing here. Where'd all those particles go? We basically lost a beaker of water. Here, we almost lost a beaker of water. Here, we lost almost a half a beaker of water. Where'd it go? So we can see that there's some errors here. You said it makes sense that the mass stays the same. Does anybody disagree with that? Eric, what do you think it should have done? What was it? Should have increased Okay, so when we add the sugar to the water, we dissolve the sugar, it should have increased. So where are the extra particles coming from? From the sugar. But we found those at the beginning though, right? Like we included those. So that's where it gets tricky, is remembering, okay, we're basically taking the number of particles of sugar that we have in this half a spoonful. We're taking the number of particles that we have in this beaker of water, and then we're combining them. So we've accounted for all the particles. So any change would be when we dissolve it, somehow particles show up, or somehow particles disappear, or they stay the same. All right? So we'll stick with that for now. Thank you. And we'll make this our last station for today, and then we'll continue tomorrow. So we got baking soda and vinegar. What happened there? When we added baking soda and vinegar together, what did they do? Bubbled up quite a bit, didn't it? What's in those bubbles? Are there any particles in the bubbles? Okay, so where'd that stuff go? Up into the air. So what do you expect would happen at this station? Should we gain mass, stay the same, or lose mass? Okay, you think we should lose mass. According to the data, we did lose mass. We lost mass. Oh, this one we gained mass for some reason. Okay, probably a measurement error. So we'll say mass lost there. Hang on to your stuff, bring it with you tomorrow, and we will continue there.